All right, let's take a look at the triads. So you planned to purchase a video game for $50. So this is your estimate. This is what you're guessing it's going to be. The actual price was $40. So this is our actual. What was your percent error? So we're going to subtract the two. So we subtract 50 minus 40. Always do your bigger number minus your smaller number. That way you get a positive. We want a positive percent. And then we divide by our actual. So by 40. So 50 minus 40 is 10 divided by 40, which equals 0.25. And then we're going to multiply that by 100, so 0.25 times 100 gives us 25%. Typically, we'd like our error to be small because that means we are only off by a little bit. So typically, whenever we are finding percent error, we want this number to be a lot smaller than 25%. But when you're just guessing for a video game and what the price would be, the percent error being a little bit more is not that big of a deal. But if we are estimating, if we're like an engineer and we're like building a bridge, we don't want our error for our mathematics to be off by a whole lot. So when something like that's happening, we want it to be very, very teeny tiny. All right, so the temperature dropped from 84 degrees. So this was my original. And then it dropped to 60. So that's my new. Still better than what we've seen here in Kansas City. What is the percent change in the temperature? So this is going back to what we did earlier in example 1, and this is going, we're going to do our original because that one's bigger. It's a decrease, minus our new divided by our original. So 84 minus 60 is 24 over 84. I'm going to divide that in my calculator. And I get 28.57. So 0.2857 times 100, because we want a percent. And we get 28 and 57 hundredths of a percent. All right.